Good morning students. Now listen carefully. Today we are going to start the problems related to the partial fractions, integration by partial fractions. Exercise 7.5, question number 1, 5, 10, 17, 19, 20, 12 and 14 I will be going on discussing one by one. Listen carefully and rest all the same variety of questions from the same exercise, question number 2, 3, 4, 6, 11 and 16. You have to solve it. Okay, integration of x upon x plus 1 upon x plus 2. First of all, we have to see whether it is a proper or improper. So degree 1, here the degree is 2, it is a proper fraction and it consists of a denominator with a non-repeated linear factors. So non-repeated linear factors, when it is there, we can write down as a upon x plus 1, b upon x plus 2. Take LCM, right side, cancel it out, we get the equation x is equals to a into x plus 2 plus b into x plus 1. Now as here we are having a linear factors and two arbitrary constants. So directly by shortcut method we can get the value of this a and b. If we put x equals to minus 2, a will be eliminated from here. So I am going to put x equals to minus 2. So minus 2 here. And minus 2 plus 1 minus b, so we get the value of b equals to 2. And one more linear factor is also available here, x plus 1. Now I am going to substitute x equals to minus 1 in equation number 3. When I substitute x equals to minus 1, this value will be eliminated and x is minus 1 and minus 1 plus 2 will be equals to 1 into a, that is a equals to minus 1. Now this value of a and b I am going to substitute in equation number 2. So x upon x plus 1 x plus 2 will be equals to minus 1 upon x plus 1 and 2 upon x plus 2. Now this complete term I am going to substitute in our question. Integration of x upon x plus 1 x plus 2 dx will be equals to a की value minus 1 integration minus dx upon x plus 1 plus 2 integration dx upon x plus 2. If we are going to take x plus 1 equals to t, dx will become equals to dt, dt by t is log t, so log x plus 1 minus log x plus 1. Here also if I am going to take x plus 2 equals to t, so dx equals to dt, dt by t will be log t 2 times of log x plus 2 plus integration constant. So here we can do directly also. Okay. Now the second question, that is question number 5. इंटीग्रेशन I is equal to 2x upon x square plus 3x plus 2. सबसे पहले हम इसको डिफरेंशिएट करके देखते हैं डिनोमिनेटर वाले को. तो 2x plus 3 we are not getting here, so we will factorize it. x plus 1 x plus 2, degree is 2, here the degree is 1, so it is a proper fraction. So only the difference in both the problem is that here I have to use splitting middle term for its factorization. So two non-repeated linear factors x plus 1 x plus 2, so it can be written as 2x upon x plus 1 x plus 2 equals to a upon x plus 1 plus b upon x plus 2. When I take LCM and cancel it, I get 2x equals to a into x plus 2 plus b into x plus 1. Again here I am getting the two linear factors x plus 2 and x plus 1, so I can easily get the value of arbitrary constants a and b. X equals to minus 2, 2 into minus 2 minus 4, this will be eliminated, minus 2 plus 1 minus b, b equals to 4. And x equals to minus 1, when I am going to take it, b will be eliminated. So 2 into minus 1 minus 2 and minus 1 plus 2, that is 1a, a equals to minus 2. Now this integration 2x upon x square plus 3x plus 2 can be written as value of a is minus 2. So minus 2 integration dx upon x plus 1, value of b is 4 integration dx upon x plus 2. And now you can integrate with respect to x, minus 2 log x plus 1 plus 4 log x plus 2 plus integration constant. Now let's turn to the question number 10. Integration of 2x minus 3 upon x square minus 1 2x plus 3. This x square minus 1 is a quadratic factor, but it can be reduced to a linear factor, as a square minus b square is a minus b, a plus b. So it becomes now here 3 non-repeated linear factors. Degree is 3 and here the degree is 1, so it is a proper fraction. 2x minus 3 upon x minus 1, x plus 1, 2x plus 3, a upon first factor, b upon second factor, c upon third factor. Now we take the LCM, the product of all these three, and the LCM will be cancelled out, both the denominators of the LHS and RHS. So we are left out with 2x minus 3, a into x plus 1 into 2x plus 3, b into x minus 1 into 2x plus 3, c into x minus 1 into x plus 1. Now here all the factors are linear. Please don't multiply. Don't open the brackets. We can apply shortcut method. First linear factor, second linear factor, third linear factor. And we are having the three arbitrary constants. So with the help of these three linear factors, we can able to find out the value of A, B and C. First, let x equals to minus 1. When we are going to substitute x equals to minus 1, minus 2, minus 3, this will be vanished out. This part will be vanished out and left out with b. So b minus 1, minus 1, minus 2 and minus 2 plus 3 plus 1, b equals to 5 by 2. Let x equals to positive 1. So 2 into 1, 2 minus 3, positive 1 x, this will be eliminated, this will be eliminated. 1 plus 1, 2 and 2 plus 3, 5. So a equals to minus 1 by 10. Now the third, 2x plus 3 equals to 0. Then x will become equal to minus 3 by 2. Now we are going to substitute x equals to minus 3 by 2 and we are simplifying. We get the value of c equals to minus 24 by 5. Now this value of a, b and c I am going to substitute and integrate it. So minus 1 by 10 integration dx upon x minus 1 plus 5 by 2 integration dx upon x plus 1 minus 24 by 5 dx upon 2x plus 3. X minus 1 if you are going to take t, dx equal to dt by t log t. Here also x plus 1 if I am going to consider as t log x plus 1. Here just listen carefully here for the 2x plus 3. If I am going to take 2x plus 3 equals to t. So what I will get the differentiation? 2 dx is equals to dt and dx will be equals to dt upon 2. That's why this 2 comes here. Okay, dx is equals to half of dt upon t. So 1 by 2 log t and t is our 2x plus 3. Clear? Here the coefficient of x was 1. So no need to worry. Here also the coefficient of x was 1, so no need to worry. But here the coefficient of x was 2. As earlier I told in integration, the coefficient of x will come to the denominator. You can see here 2x plus 3 equals to t. When we are going to differentiate it, 2 dx equals to dt, dx equal to dt by 2. So that's why 1 by 2 log 2x plus 3 and becomes 12 upon 5 log 2x plus 3. That is our final answer. Now next comes to question number 17. Integration cos x upon 1 minus sin x into 2 minus sin x dx. It is also a partial fraction question. By seeing the question directly we can see that if I am going to take sin x equals to t, its differentiation is cos x dx equal to dt. So numerator will become cos x dx will become dt and the denominator will become 1 minus t, 2 minus t, non-repeated linear factors in a variable t. As in the previous questions we are proceeding in the linear factors in a variable x. Now it is converted into a linear factor of in variable t. So same process you have to calculate value of a and b and then integrate it. But here there is a slight difference in the integration of x minus 1 dx upon x minus 1 and integration of dt upon 1 minus t. Okay, listen here, if I am going to take x minus 1 equals to t for this case, okay, I will be getting dx equal to dt. The value will be positive. Clear? But here in this problem, both the cases you can see 1 minus t and 2 minus t. The variable coefficient is minus. Now here if I take 1 minus t is equals to suppose u, then minus of dt will become equals to du, and dt will become equals to minus du. Okay, so whenever the integration of negative coefficient comes, there will be a one minus sign also. dt du by u log 1 minus t, du by dt 1 minus t, differentiation will be minus 1. In the same way 2 minus t, if I am going to take suppose 2 minus t is equals to v, so minus of dt will be equals to dv, dt will be equals to minus of dv. Okay, so here also we will get a one minus sign. So minus log, substituting the value of t as sin x, 1 minus sin x, minus into minus plus log 2 minus sin x plus integration constant c. As we know that log m minus log n is log m by n. So log 2 minus sin x upon 1 minus sin x plus c is your final answer. Now let's move to the question number 19. Integration of 2x upon x square plus 1 into x square plus 3. It is the most important question. Let x square, if you are going to take x square equals to t, the differentiation of x square is 2x. So that's why we are going to take x square equals to t. We are getting the numerator 2x dx equal to dt. So this complete function is converted to now integration of dt upon t plus 1 t plus 3. Now it becomes non-repeated linear factor in a variable t. So 1 upon t plus 1 t plus 3 equals to a upon t plus 1 plus b upon t plus 3. In the same way we will proceed and we will get the value of a as 1 by 2, value of b minus 1 by 2. And this value of a and b I am going to substitute it here and integrating also. So integration of dt upon t plus 1 t plus 2 will be equals to value of a is 1 by 2, dt upon t plus 1, and value of b is minus 1 by 2, and integration dt upon t plus 3. So 1 by 2 dt by t plus 1. T plus 1, if we are going to take as u, dt will become equals to du by u log u, and u is our t plus 1. In the same way, we will get integration of dt upon t plus 3 log t plus 3. So 1 by 2 I have taken common. When 1 by 2 is taken common, log t plus 1 minus log t plus 3. So log m minus log n is given by log m by n. So 1 by 2 log t plus 1 upon t plus 3 plus c. At last we have to substitute the value of t, x square plus 1, x square and x square. It becomes x square plus 1 upon x square plus 3. Remember one thing. If you are taking any variable equal to t and you are differentiating here, then here you have to integrate with respect to t. If you are substituting the value of t here, you have to integrate that function with respect to x variable. So better to integrate with respect to t variable, and at last in the final answer you substitute the value of t which you have taken earlier as x square. Now question number 20. I equals to integration dx upon x into x to the power 4 minus 1. If you are going to take x to the power 4 equals to t, we will get in 4x cube dx. But in the numerator of this question there is no any x cube. So what we will do? We will multiply the numerator and denominator with x cube. So x cube dx or x into x cube x to the power 4. Now if we can take x to the power 4 equals to t, its differentiation will be 4x cube dx equals to dt. So x cube dx will become dt by 4. So dx dt by 4 and x to the power 4 is t. So t minus 1. Now this integration question has been converted to a non-repeated linear factor. So in the same way 1 upon t minus 1 equals to a by t plus b upon t minus 1. First, there is only one variable, one linear factor t. No constant is there. T minus 2, t plus 3, t plus 7, nothing is there. So what value we have to take here for getting the value of the arbitrary constants a and b? So here we will take 0. t equals to 0 लेंगे तो a की वैल्यू -1 and the second linear factor is we are having t -1, so here we will take t equals to 1, so we will get the value of b equals to 1 and we will substitute value of a -1, so as it is here 1 by 4, so minus 1 by 4 dt by t and value of b is 1, so 1 by 4 b आएगा और integration dt upon t minus 1. So in the same way minus 1 by 4 log t plus 1 by 4 log t minus 1 plus c. Every time there will be no log integration. हर समय we are seeing in the all the previous questions many times we are integrated and we are getting the log answers in log. But it is not compulsory that every time we are integrating we will get the log term only. Okay, so log t minus 1, so 1 by 4 common, log t minus 1 minus log t can be written as log t minus 1 upon t as log m minus log n is equals to log m by n plus integration constant. At last we can substitute the value of t as we have taken x to the power 4, so 1 by 4 log x to power 4 minus 1 upon x to power 4 plus integration constant. Now next question number 12. The difference is that till now we are integrating the proper fractions. Now we have to integrate improper fraction. Degree is 3, here the degree is 2. If the degree of the numerator and denominator polynomial are equal, or the degree of the numerator polynomial is greater than the degree of the denominator polynomial, then it will be improper. So first this improper fraction we have to convert into the proper form by division of the polynomials as we are studying in class 9th. X cube plus x plus 1 and x square minus 1. Dividend and divisor. Another thing in improper fraction you have to see that whether the dividend and divisor are in the standard form or not. If they are not in the standard form, you have to write down in standard form both the dividend and divisor and then only you have to proceed for division. So x cube minus x, change the sign, x plus x 2x plus 1. In class 9 you have studied that when the remainder comes equals to 0 the division stops, but in this case the remainder will never come equals to 0. If remainder will comes equal to 0, then this part of integration will be vanished out from there. So, and the second case when the division of the polynomial stops is that when the degree of the remainder becomes less than the degree of the divisor, our division stops. Here one rule is applicable in the division case of polynomial. If the degree of the remainder, that is 2x plus 1 degree remainder is 1, degree of this remainder is 1 and degree of the divisor is 2. So 1 is less than 2. So here the degree of the remainder is less than the degree of the divisor. So our division stops. Which can be now written as quotient plus remainder upon divisor. Quotient plus remainder upon divisor. So this complete term can be written as quotient x plus remainder 2x plus 1 upon divisor x square minus 1 dx. Now we can separate integration of x dx, integration of 2x plus 1 upon x square minus 1. Now here integration x dx we can integrate directly, but this function now it is converted into the proper fraction. As you can see that 2x plus 1 degree is 1 and x square minus 1 degree is 2. Now the degree of the numerator polynomial becoming less than the degree of the denominator polynomial, so it is proper. Now we have to proceed in the same manner as we have done the previous questions. So a upon x minus 1 plus b upon x plus 1, get the value of a and b. Value of a 3 by 2, value of b 1 by 2. Now after getting the value from equation 1, integration x dx plus 2x plus 1 upon x square minus 1 is written as a upon x minus 1, a value is our 3 by 2. So 3 by 2 integration dx upon x minus 1. B value is our 1 by 2, substitute b 1 by 2 and integration of dx upon x plus 1. When we integrate these three terms, we get x square by 2, 3 by 2 log x minus 1 plus 1 by 2 log x plus 1 plus c. And that is our final answer. Now, today's last question, question number 14, I equals to integration 3x minus 1 upon x plus 2 the whole square dx. So, this we can solve by a very shortcut method. If there is a repetition of a single linear factor, then only we can apply this method. Okay? अगर हमारे पास एक ही लीनियर फैक्टर है जो रिपीट हो रहा है और इसके अलावा कोई दूसरा फैक्टर नहीं है लीनियर फैक्टर डिनोमिनेटर, then only you can apply this method. Take x plus 2 equal to some other variable, get the value of x from here, y minus 2, and differentiate this. Dx equals to dy. So dx equals to dy. In place of x in the numerator, you put x equals to here y minus 2. You got it from the equation. And minus 1 upon this will become a monomial term y square. Open the bracket, 3y minus 6 minus 1 upon y square dy, integration 3y minus 7 upon y square. As the denominator is now here is the monomial term, we can separate it out. 3y upon y square will be 3 upon y dy upon y minus 7 dy upon y square. 3 integration dy by y minus 7 integration y to the power minus 2 dy. After integration we get 3 integration dy by y log y minus 7 x to the power minus x to the power n plus 1 upon n plus 1. So we get y to the power minus 2 plus 1 upon minus 2 plus 1 plus integration constant. So integration 3 log y plus 7 upon y plus c, and as the value of y is our x plus 2, at last after integration with respect to y, you substitute in place of y x plus 2. So 3 log x plus 2 plus 7 upon x plus 2 plus integration constant. Now today I have explained you about 1, 2, 3, 4, 5, 6, 7, 8 questions. 8 questions. First was the non-repeated linear factors variety, one variety. Second variety was we are taking, assuming the function as t and converting them to a non-repeated linear factors in terms of another variable as a t. And third, for improper fraction, first you divide the polynomial, convert it into proper form, and write down that complete improper fraction in the format of quotient plus remainder upon divisor. And the fourth variety is in front of you, that is single linear factor which is repeated. No any other factor is there with it. खाली एक ही फैक्टर रहेगा जो रिपीट हो रहा है और उसके साथ कोई another factor will not be there. Then only you can apply this. In my next class, I will be discussing some more questions. Still, the partial fractions, some of the variety of the questions are left out when there will be a repeated linear factors as well as non-repeated factor also will be there with it. And irreducible quadratic factors are also there in the given integration functions in the denominator of it. So, thank you. Study well, work hard and try to score good marks. I know that you all will work hard and you all will score very high marks in mathematics. Thank you.